Welcome. In this video, I'm going to work out some problems similar to the problems on homework 8. Right here, I actually took problem 2 from homework 8 and just changed two numbers, and I'm going to work this out one step at a time. So this question says that we're imagining that a student has 5 friends who are taking a certain class, and these are the current grades of the 5 friends. And the student is thinking about taking this class, but is concerned that the class might be difficult. So the student decides to survey his or her friends, asking them how well they're doing in the class. But for some reason, the student doesn't want to bother all 5 friends, so the student decides to randomly select 3 friends out of 5 and survey those 3 people on how well they're doing in the class. And part A says, how many combinations of 3 friends are there in this situation? In other words, how many ways are there for this student to select 3 people from 5 people? Well, to get the answer, you have to use the combination formula that we learned earlier. Remember that if order isn't relevant, if order doesn't matter, you use the combination formula, not the permutation formula. In this situation, order doesn't matter because the order that the student selects the 3 friends in has no effect on what the outcome of the survey will be. All that matters is which 3 people are chosen. So if the student ends up selecting friend 1, and then friend 2, and then friend 3, that's going to lead to the same outcome as if he or she had surveyed 3, then 2, then 1, because it's still the same 3 people. The 3 answers will be the same, and the order that they're surveyed in makes no difference. So we're using the combination formula because order doesn't matter. So remember, in this notation, x is the number of selected items, n is the number that are being selected from. So we're selecting 3 from 5, so x is 3, n is 5. I know that this might be confusing because in other topics in this class, little n is actually sample size, and capital N is population size. But it turns out that in the combination notation, x is actually the sample size, and the little n is the population size. But I know it's inconsistent, but it's just the notation that's used in different topics. So we have 3 from 5, so x is 3, n is 5. We plug these numbers in. 5 minus 3 is 2, and I worked out a little bit more of it for you right here, but just finish the work that I didn't complete, and you should end up seeing that there are 10 combinations. And remember that you can't cancel a number more than once. So if you cancel 3, 2, 1, and then 3, 2, 1, those numbers are already gone, so you can't go back and cancel 2 and 1 right here with 2 and 1 down here. I've seen some people do that, but you can't do that because these numbers are crossed out and they're already gone. They can't be reused. So you can't, like I said, you can't just cancel this 2 times 1 with this 2 times 1. Now we need to actually determine what the combinations are of 3 friends, what the possible combinations are. So what we do now is we write these numbers out: 1, 2, 3, 4, and 5. There's a step-by-step process we can follow to find out what the combinations are. So I numbered these 1 through 5 because these represent the 5 people in the population, the 5 friends. So it's friend 1 up to friend 5. What we do now is we start at 1, and we under 1 we write out the numbers that come after 1. So there are 5 friends. So the numbers that come after 1 are, let's see, 2, 3, 4, and 5. And we stop at 5 because there's only 5 people in the population. Then we write out the numbers that come after 2. So it's 3, 4, and 5. Then we write out the numbers that come after 3, which are only 4 and 5. And then we write out the numbers that come after 4, which is just 5. And then we write out the numbers that come after 5, which are nothing, so we actually don't need this. And what we have now are the possible combinations of 2 people. The possible combinations of 2 people that could be chosen are 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, and 3, 5. So what we do now is we go one level further, and we start at 2, and we write out the numbers that come after 2. So I need to create some more space right here. So after 2, you have 3, 4, and 5. And we don't go past 5 because there's only 5 population members. And then after 3, we have 4 and 5. And then after 4, we have just 5. And then we don't have anything after 5. So we actually just stop right there. And actually, this isn't going to be one of the possible combinations of 3 because it's a dead end. Then we move on right here, and we write the numbers after that follow 3, which are 4 and 5. And then after 4, it's 5. And then after 5, there's nothing. So we stop there. And then after 4, right here, there's a 5. And nothing after 5 right here, because there's only 5 population members. And nothing after 5 right here, so we actually stop there. And now let's count how many combinations we have of 3 people. So we have, let's see, let's follow this tree. So we have, the first one is 1, 2, 3. Then we have 1, 2, 4. And then, 1, 2, 3, 1, 2, 4, and 1, 2, 5, just following down the branches. Then we have 1, so that's 3 already, combinations. Now we have 1, 3, 4, and 1, 3, 5. So that's 5 combinations now. Then we have 1, 4, 5, which is 6 combinations. And then, let's see, 2, 3, 4, 2, 3, 5, 2, 4, 5, and 3, 4, 5. So that is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, all 10 combinations. So now let's write them out over here. So I just wrote them out. So just write them out like I did, just separated by commas like this. So show your work over here with the branches, and then over here, just write them out separated by commas. And now we move on to part C, which is write out the possible samples of 3 friends, along with their data values and sample means, and also write out the sampling distribution as a column of numbers. So let's move on to part C right now. In part C, I'm actually going to have you write it out like this. So just take the combinations from part B and just write them out down here under the word persons. And it doesn't matter which order you put them in, as long as that they're all there. And then in this column that says data, write out the 3 grades of, or the 3, 3 grades or 3 data values of each of the 3 people. So in part C, I'm actually going to have you write it out like this. So write the word persons, and then under that, take the combinations from part B and put them So I'm actually going to have you format part C like this. Write the word persons, and then take the 10 combinations from part B and write them out under the word persons. It doesn't matter what order you write them in as long as that they're all there. And then under the word data, write the 3 data values that go along with the 3 people. So here we have person 1, person 2, and person 3. So let's look up their 3 grades in the class. So person 1, person 2, and person 3 are 70, 80, and 85. We're just following the order that I wrote them in up here. So these are in the question, it's person 1, person 2, 3, 4, and 5. We're following that order. So person 1, person 2, and person 3 are, like I said, 70, 80, 85. And now what we need to do is we need to get the mean of this first possible sample. So to get that, we just add the 3 data values and divide the total by 3. So it's going to be 70 plus 80 plus 85. Divided by 3, and we get 78.3. So we can actually round to whatever decimal place we want as long as we do it the same way for all of the possible samples. But I'm actually going to have you round each one to 1 decimal place. So it's 78.3. And now let's move down to person 1, person 2, and person 4. So let's go up here again. So person 1 is getting a grade of 70. Person 2 is getting a grade of 80. And person 4 is the 90. So it's going to be 70, 80, and 90. And just like before, we need to get the mean of this combination. So we add the 3 numbers and divide by 3. 70 plus 80 plus 90 is 240. Divided by 3 is 80. So yeah, this does have a mean of 80. And we just keep going down until we're finished with all of our combinations, until we do it for all 10 of them. So I actually finished all of the work right here. So I didn't show all of the combinations under the word data, but in your homework, just show all of the possible combinations in this column. And then here I have the mean of each combination. So I just kept going down, and every time I added the 3 numbers and divided by 3 to get the mean of each of these separate combinations. So now I have the complete sampling distribution. So remember that the sampling distribution is has 1 statistic for each possible sample. So now we move on to part D. So part D says to make a diagram of the sampling distribution and label the probability of each possible outcome. So let's look back to part let's look back to part C, which I just finished. So we need to take these 10 numbers and plot them in a diagram. So first I just need to decide what tick marks I think are appropriate. So it looks like the numbers go from 78.3 to 91.7. So I don't want to list every single number on my x-axis, but I could start at 75 and just go up by 5s. So here I have 75, 80, and 85. And then 90. And um, and I'll go up to 95. So you can just use whatever tick marks you think are appropriate. I'll let you use your own judgment. And what I need to do now is just plot the sampling distribution, those 10 numbers on this diagram. So I'm just going to make some X's on here to show the data values. I'm sorry, the numbers inside the sampling distribution. So let's look back at the first one. The first one is 78.3. So I'll put that right here. It doesn't have to be perfectly accurate, just put it roughly at the right place. So that's 78.3. Then I have 80. So I'll put this right here for 80. And then we have 83 point, I'm sorry, then we have actually 81.7. So I'll just put that one right here. And then we have actually two 85s. So we need to stack those on top of each other. So if two of the numbers are the same, it's actually important to put them right above each other, because that'll help us calculate the probabilities. So we have two 85s. Now we have an 86.7. I'll just put that right here, just at roughly the correct place. Then we have, let's see, 88.3. And then we have 90, and we also have 91.7. I might have left one out by accident, but I included it now. So now we have all 10 numbers. Now what we can do is we can find the probability of each possible outcome. So when this person randomly selects 3 people, there is a, let's see, a 1/10 probability that the sample mean will come out to this number. There is a 1/10 probability that the sample mean will come out to this number. So just like I'm doing, write out the fractions above the numbers to show the probabilities. This one is also 1/10. There is a 2/10 probability of the sample mean coming out to this number. You don't have to reduce, so it's fine to write 2/10. Here, this is 1/10. And actually all of the others are 1/10 because 85 is the only number that repeats. So what we're writing here is just the probability of the sample mean coming out to this number when the 3 people are randomly selected. And now we are finished. We're finished with this diagram. So this next question says, in this situation, what's the probability that the student will randomly select 3 friends with a mean grade of 85? So what we've actually done here in part D prepared us to do part E, because now all we have to do is look up 85 inside of our diagram, and we can see that 2 out of 10 combinations have a mean of 85. So the answer is 2/10. So I said you can either write the answer as a fraction or as a decimal. So if you just write 2 over 10, that would be fine. Now let's move on to part F. So part F says, in this situation, what's the probability that the 3 selected people will have a mean of 80? Well, if we can see here that if we look at all 10 combinations, only one of them has a mean of 80, 1 out of 10. So the probability would be 1 over 10, because 80 never repeats inside these 10 numbers. I'm actually going to skip part G because it's just another type of question just like E and F. But before I move on, I'm actually going to recap how we got here. So let me actually go back to part A just for a second right here. So just to recap, we know that this in the question, it said that there are 5 friends in the population, and this student is going to randomly select 3 of them out of the 5, and then record their 3 grades. And since we're told that the person is selecting 3 out of 5, that's what told us that we're dealing with combinations of 3. And that's why we used 3 as x in part A in our combination formula. And it's why we wrote out the combinations of 3 in part B. And it's also why we calculated the mean of all possible combinations of 3 in part C. So the question told us that we're dealing with 3 out of 5. Well, 3 out of 5 are being selected. And then that told us right away that we're dealing with combinations of 3. And that's why we've been dealing with combinations of 3 all along. So you have to look at the problem to find out what sample size you're dealing with. And then when we did the sampling distribution and calculated the means of all possible samples of 3, that's what actually prepared us to do parts E and F. Because once we made this diagram and we found the probability of each possible number that the sample mean could come out to, then once we got to part E, we could just look up the number that the question is asking about and get the answer from the diagram. So this has all been leading up to parts E and F. Now let's move ahead and go to part H, because like I said, I'm skipping G because it's just another question like E and F. Part H says to calculate the mean grade of the population. So basically calculate the mean of the population. So to do that, all we have to do is add the 5 numbers and divide by 5. So the grades are, let's see, 70 is the lowest one. Then we have 80, 85, 90, and finally 100. These are the grades of the 5 friends in the population. So to get the mean of the population, we just add the 5 grades and divide by 5. And it should, if you do the work, it should come out to 85. At least in my example, because your numbers aren't the same as mine, so yours might come out to a different number. But that's all you have to do for part H. Part I says calculate the mean of the sampling distribution. So what you have to do is just follow the same format that you did for part H. Just add in this case, add the 10 numbers. Well, I would add the 10 numbers and divide by 10. So let's go back and find out what those 10 numbers are. So this was the sampling distribution from part C. So what I do now is I just add these. I would add these 10 numbers and divide by 10, and I would get the answer. So I'm actually not going to show the work for this one. Just follow the same format as question H for showing work. Because like I said right here, I would just be getting the mean of 10 numbers. And the next question says, part J says, did the mean of the population and the mean of the sampling distribution come out to the same number? Well, if you did the work correctly, they always come out to the same number. So if I did the work for part I would also get 85, assuming I did it correctly. So part J should come out to yes. If it doesn't come out to yes, then go back and double check the work that you did. So I'll just put yes right here. Like I said, the mean of the population and the mean of the sampling distribution come out to the same number. Right here I have a problem similar to problem 3 in the homework. And in this problem, the values are actually categories and not numbers, which tells you that it's going to be a problem involving proportions instead of means. So in this type of sampling distribution probability problem, if the values are numbers, that's telling you that you're going to be dealing with means. And if it's categories, it means you're going to be dealing with proportions. So just know that going into this type of problem. And it says right here that these are the 5 friends, and the student is once again thinking about taking this class, but is concerned that the class might be difficult, and the student doesn't want to bother all 5 people. So once again, the student takes a sample. In this case, the student selects 2 out of 5 friends and asks each of them if he or she is passing the class. So I actually made this one 2 out of 5 instead of, I think in your problem it's 2 out of 4. And the first part A once again says how many combinations, how many possible combinations are there? Well, just use the combination formula. Just like I showed you in my last example. For 2 out of 5, and well, my example it's 2 out of 5. For you, it might be something different. And actually, if I did the work, 2 out of 5 would actually be 10 combinations. That would be the answer. Part B now says to actually list out the possible combinations. So once again, we're going to be making the same type of tree diagram, this time to find the possible combinations of 2. So once again, there are 5 population members. So I'm going to be writing 1, 2, 3, 4, and 5. So under here, I'm going to be writing the numbers that come after 1. And just like before, it's going to be 2, 3, 4, 5. And actually, I stop here. I don't go down to another level because I'm trying to get the combinations of 2 people. Because the question says that the student is taking a sample of 2 people, which means that I'm dealing with combinations of 2 this time, not 3. So see how it says 2 right there? So I stop right here. I don't go down an extra level. So after 2, you have 3, 4, and 5. After 3, you have 4 and 5. And after 4, it's 5. And there's nothing after 5, so stop there. And now I have my combinations of 2. The combinations are 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, and 3, 5. And just like you did in the earlier problem, just write them out over here, separated by commas. And now let's move on to part C. So part C is telling us to write out the possible samples of 2 friends. In other words, the possible combinations of 2 friends. with their data values and for us to calculate the proportion of each sample that's passing the class. So notice how this time it's not asking us to calculate a mean. Last time it asked us to calculate a mean, but this time it's asking us to calculate the proportion of each sample that's passing the class. So we'll do that this time. So once again, let's write out the possible samples. So this time each data value is not a number, it's actually a category. It's passing or not passing. So let's look back to our data set. So we have these 5 people. Person 1 and person 2 are not passing and passing. So I'll just write NP and P. Person 1 and person 3 are not passing and passing. It's the same. Person 1 and person 4, not passing and passing. One and 5 is the same. No, I'm sorry. Actually, 1 and 5 are 2 not passing. They're both not passing the class. And let's see. Actually, I didn't do this correctly. 1, 2, 1, 3, 1, 4, 1, 5. There is no 1, 6. Sorry, let me fix this. So now this is actually correct. These are the 10 combinations I'm dealing with. So now I'm just going to continue and go down and fill in the rest of these. So now I filled in all of my data values for all of these possible samples of 2 people. Now I'm ready to create the sampling distribution. And notice how the directions are telling us to calculate the proportion of each sample that's passing the class. So a proportion is just a percentage written as a decimal. For example, if a sample is 50% passing, then you would say that the proportion is 0.50. Or if a sample is 25% passing, you would say that the proportion is 0.25. So it's just a percentage written as a decimal. So to get the proportion that's passing, what you actually do is you count the number of people who are passing and divide that by the total number of people in the group. So let's start with person 1 and person 2. In this group of 2 people, 1 person is passing and there's 2 people. So 1 out of 2 are passing. So what you would do here is 1 divided by 2, which as a proportion would be 0.5. So it's half passing. The same thing here. If it's an NP and a P, it's 1 person passing out of 2 people. So once again, 1 out of 2 is 0.5. The same thing here. And just keep going down. Now here we actually have 0 people passing out of 2 people because it's 2 NPs. So it's 0 divided by 2, which is just 0. Here we have 2 people passing out of 2 people. 2 divided by 2 is 1. So it's 100% passing. Here it's again PP, so it's 2 over 2, which is 1. Here we have another 0.5. So each time I'm just counting the number of people who are passing and dividing by 2. 1 out of 2 again. And now we are finished. So now I'm ready to go on to part D, which is creating the diagram of the sampling distribution. So let's move on to part D right here. And just like before, just use your own judgment to pick what the tick marks are. So in this case, the numbers are 0.5 and 1. So all I need is just 2 tick marks. Actually I have 0, 0.5, and 1. So I need 3 tick marks. So how many zeros do I have? Well, I have two of them. Let's see how many 0.5s. 1, 2, 3, 4, 5, 6. How many ones do I have? Well, only two. So now this tells me what the probabilities are. So when this student randomly selects two people from the 5, there is a 2 out of 10 probability that the sample will be 0% passing. There is a 4 out of 10 probability that the sample will be 50% passing, or 0.5 passing, and a 2 over 10 probability that the sample will be 100% passing. And now we are finished. So now we're ready to move on to part E, in which we just look up one of these probabilities. Part E says when this student randomly selects the two friends from the population, what's the probability that the person will get two friends with a sample proportion of 0.5? In other words, a sample of two people that's half and half, one passing, one not passing. Well, we can just look at our diagram. 4 out of 10 of the possible samples are 50% passing, which means that the probability is just 4 over 10. We just look it up from right here. And the probability parts F and G are just other versions of part E, other versions of the same type of question. So I'm actually going to skip over those and move on to the next part of the problem. So now part G says, calculate the proportion of the population that's passing the class. And in my example, it's actually 5 people because I changed the number, but for you, it's 4 people. So if we look back to the population from the very beginning of the problem, it said that that there's 5 people and 2 of them are no, 3 of them are passing and 2 of them are not passing. So to get the proportion of the population that's passing the class, we would just divide 2 by 5 and get a decimal. And the answer would be 0.4, which is just 40%. So let's actually look back to the beginning of the problem. So back here at the beginning, we see that there's a population of 5 people. And if we want the proportion that's passing of the population, we just count the number that are passing and divide that by the total number of people. So let's see, there are 3 passing. So it's 3 divided by 5, which is 60% passing. So let's go back to that part of the problem. So I'm actually wrong. I'm sorry. It's actually 3 out of 5 people are passing, which means that the proportion of the population that's passing is actually 0.6, which is 60%. And now it says calculate the mean of the sampling distribution. So just add the 10 numbers and divide by 10, like we did in problem 2, and that'll be your answer. So in my example, I would add these 10 numbers and divide the total by 10, and that would be the mean of the sampling distribution. And then part I says, did the population proportion from part G come out to the same number as the mean of the sampling distribution in part H? And if you did everything correctly, the answer would be yes, because the in a situation involving a sample mean, the mean of the sampling distribution equals the mean of the population. And in a situation involving proportions, the mean of the sampling distribution equals the population proportion. So if I did the work in part H and I did it correctly, it would come out to 0.6. And this is actually the end of this problem right here. So I've shown you two examples, one for a mean and one for a proportion, and that should cover all of the situations on your homework 8. Um, so there, so the sample size or the population size might be different in your question, um, which um, which means your question might be slightly different than the examples I did. Also, your questions have different data values, but I think I've covered all of the step-by-step information that you need to know um, that you can apply to really any version of this type of problem. So just let me know if you have any questions, and that's it for this video.